Welcome all of you dear students. Wishing you all the best and blessings for Deepavali festival which is celebrating in all over India. This is the simplest and easiest way of teaching learning process in our most popular YouTube channel Physics Make It Simple by Dr. Rajendra Kobarne, now serving as a principal in Lokanete Dr. Balasaheb Vikhe Patil, Padma Bhushan Awardee, Pravara Rural Education Societies, Mahatma Phule Vidyalay and Junior College, Dad Budruk Taluka, Rahata District, Ahmednagar. As long as 12 Science Wave Optics is concerned, this is a lecture number 8, and in this lecture we are going to discuss about magical article polarization of light and Malus law. Dear student, before demonstrating this article in front of you, I have discussed this article with some physics experts, physics teachers from Ahmednagar district physics teachers WhatsApp group. They have taken a participation and made a discussion with me to make this article in a simplified form, so that I will now able to demonstrate in front of you in a very simple way. So I express my views to the bottom of my heart for all teachers, those have participated to discuss this article. So I am very interested to mention that all expert teachers in front of you, that teachers are one by one. The first one is that most senior and retired physics teacher Mr. Shantinath Patil sir from Govindrao Junior College, Ichalkaranji district, Sangli. The second one is that my very close friend Parag Solanki sir from JTS Junior College, Belapur district, Ahmednagar. Third one is Mr. Sohail Rahi sir, Sanjeevani Junior College, Kopargaon district, Ahmednagar. Fourth one is Vishal Shinde sir, Chandaneshwar Junior College, Chandanapuri Taluka, Sangamner. Fifth one is Vivek Chaudhary sir, Chaudhary Physics Classes, Ahmednagar. Sixth one is Suresh Salunke sir, Headmaster Pandit Jawaharlal Nehru Vidyalay, Adhalgaon Taluka, Shrigonda. Seventh one is Ashok Sherke sir, Chhatrapati Shivaji Mahavidyalay, Shrigonda. Eighth one is Irshad Pathan madam, Headmistress Sona Sonsali Kanya Vidya Mandir, Karzat. And last one Anjali Keval madam, Pragat Junior College, Ahmednagar. So before starting directly the polarization, I want to discuss about what is Huygens wave theory. 2 points of Huygens wave theory is that Huygens suggested light is in the form of mechanical wave, dear students, and light is in the form of longitudinal wave as well. So since it is stated as a mechanical wave, material medium is necessary for its propagation. So Huygens assumed that hypothetical imaginary medium ether is present everywhere, and that light is propagating in the form of longitudinal wave. But both these assumptions are refused by doing experimental verification by another scientist. Maxwell is the scientist who suggests that light is in the form of electromagnetic wave. Material medium may or may not be necessary to propagate electromagnetic wave. We call it as EMW wave. This is the first point. And the second point is that Huygens suggested that hypothetical medium ether is present everywhere. But Michelson and Morley, these are the two scientists who suggest that such a hypothetical medium ether does not exist in nature. And so that whatever suggested by the Maxwell, that light is in the form of electromagnetic wave, is agreed and proved and verified throughout. Since light is in the form of electromagnetic wave, we should know the history, production, concept and properties of electromagnetic wave, dear students. Listen carefully. To learn more detail about electromagnetic wave, you will have to see my YouTube lecture that I have already uploaded while discussing the chapter Electromagnetic Wave of 11th Science. So, listen, observe first lecture of electromagnetic wave at first to get clear-cut idea about electromagnetic wave. Okay. But as long as the polarization is concerned, what is electromagnetic wave? Electromagnetic wave consists of two components. The first one, electric field vector E vector and magnetic field vector B vector. Such a two components are perpendicular to each other, and they are not only perpendicular to each other, but they are also perpendicular to the direction of propagation of wave. Such a wave is called as electromagnetic wave. See here, I will show with the help of pen like this. So suppose this is electric field vector E, this is electric field vector E, this is magnetic field vector B, and this is the direction of propagation of wave, and the wave is propagating like this. See here, the wave is propagating like this. These two are perpendicular to each other. They are not only perpendicular to each other, but also perpendicular to the direction of propagation of wave. So I will draw the diagram over the board. See here, electromagnetic wave. This is the direction of propagation of wave. Direction of propagation of wave, and this is what? This is electric field vector E, like this, electric field vector E, and this is magnetic field vector B. This is the nature of electromagnetic wave. Then come to our original point. As long as the polarization is concerned, dear student, only concentrate the component electric field vector, or best way we can say that electric field vector E vector is a most responsible component to study phenomenon of polarization. How it is, that we will see now. So let us clean the board at first, and then let me title the article. That article is what? The first article is unpolarized light. Unpolarized light. Polarized light. Polarized light and partially polarized light. Partially polarized light. Partially polarized light. Unpolarized light. Partially polarized light, sorry, and then partially polarized light. So let us see the first one, unpolarized light. I will write here, unpolarized light. Unpolarized light. Unpolarized light. How the unpolarized light is shown? Unpolarized light, let us take a plane like this. Let us take a plane like this. Okay. And direction of electric field vectors are like this. See here. This is the direction of electric field vectors, like this, like this, like this, like this, like this, like this. These are the directions of electric field vectors, and from these diagrams, we are able to explain the definition of unpolarized light, dear student. How we can define it? Vibrations of all electric vectors. This is first electric vector, second, third, fourth, fifth, sixth, seventh, eighth, and so on. N number of electric vectors. Vibrations of all electric vectors occurs symmetrically in all possible directions, in a plane, and that plane is perpendicular to the direction of propagation of wave. This is the direction of propagation of wave. Have you understood this? No, I think you can't understand this. See here, this is a plane. Let me take a plane surface like this. Suppose this is a plane and direction of electric vectors are like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. These are the all possible directions of electric vectors, and that all possible directions of electric vectors are in a certain plane, and this plane is perpendicular to the direction of propagation of wave. We call it as unpolarized light, or it is called as an ordinary light. Sunlight is a very good example of unpolarized light. So I will write a definition of unpolarized light. A light in which vibrations of all electric field vectors E vector occur symmetrically in a plane. This is plane. The plane is like this. This is plane. This is plane. And direction of propagation of wave is like this, in a plane which is perpendicular to the direction of propagation of wave. This light is called as unpolarized light, is known as unpolarized light, is known as unpolarized light. Sunlight is a very well known example of unpolarized light. I will write here, for example, sunlight. So how the symbol of unpolarized light is to be detected? Like this here. Directions are in all possible ways. Directions of electric vectors like this, and dot is given here like this. This is unpolarized light. This may be written like this. having dot in the middle. This may be written like this. Directions of electric vectors are in all possible ways. These are all the symbols of unpolarized light, and this is the direction of vibration of electric vectors. So, a light in which vibrations of all electric vectors occur symmetrically in a plane, in all possible directions. I will correct this, in all possible directions, which is perpendicular to the direction of propagation of wave, is known as unpolarized light. Sunlight is a very well known example of unpolarized light. Then we will see what is polarized light. Let me clean the board. So take a screenshot at first. A light which vibrates of all electric field vectors occurs symmetrically in all possible directions in a plane. We can write like this: in all possible directions in a plane, and that plane is perpendicular to the direction of propagation of wave. This is more correct. So instead of writing here in all possible directions, we can write here occurs symmetrically. Here we can write in all possible directions, and then write down this in a plane. This is a plane, and that plane is perpendicular to the direction of propagation of wave, is known as unpolarized light. Okay, and these are some symbols that I have tried to draw to show the symbols of unpolarized light. Okay, then next article is polarized light. What is polarized light? What is polarized light? I will write here polarized light. Okay, so I will draw a symbol of unpolarized light at first. This is a symbol of unpolarized light, and I keep what? I keep a polarizer. I will explain what is meant by polarizer. It is called as polarizer or Polaroid. Polarizer is a plane made up of tourmaline crystal whose, suppose, polarizing axes are vertical, like this. And when such a polarizer, which is made up of tourmaline crystal, a particular type of glass, and that plane is whose plane is placed vertically in front of the unpolarized light. Here it is unpolarized light. Then what happens? After emerging the ordinary light or unpolarized light, it is also called as ordinary light. After emerging ordinary light through the plane of the polarizer, then only those electric vectors are passed through the polarizer whose directions of vibrations of electric vector is exactly parallel to the polarizing axis of polarizer. Polarizing axis of polarizer is vertical. So only vertical vibrations of electric vectors can pass, like this. If the polarizing if the polarizing axis is like this, if the polarizing axis is like this, then only such a type of vibrations are coming out. If polarizing axes are like this, if the polarizing axes are like this, then only such a type of vibrations of electric vectors are coming out from the polarizer. In the diagram, polarizing axes are vertical. So only vertical component, only the vertical vibrations of electric vectors can pass, and this is called as polarized light. Polarized light. So vibrations of electric vectors are in a particular single direction, only one direction. Another directions are blocked by the polarizer, and the light we got, that light is called as polarized light, dear student, and the phenomenon is called as polarization. Photosun goggle is the very well known example of polarizer. So while writing the definition of polarized light, how we can write? A polarized light in which, I will write here. So let me clean the board at first. I will write a polarized light, in which vibrations of all electric vectors, that is E vectors, occur only in one direction. Where? In a plane. And that plane is perpendicular to the direction of propagation of wave. In a plane perpendicular to the direction of propagation of wave. Direction of propagation of wave is known as polarized light. That I have already written here. A polarized light in which, okay, is known as perpendicular to the direction of propagation of wave, and the phenomenon is called as polarization. And during polarization, when the polarized light is coming out through the polarizer, then intensity of the polarized light is half the intensity of unpolarized light. It clearly indicates that, dear student, suppose the intensity of unpolarized light is 100, then intensity of polarized light becomes 50 only. But again question arises, only the vertical vibrations are coming out, only one vibration is coming out, which is vertical. How it becomes 50%? The answer is very thinkable. See here, this is an inclined vector, this is an inclined electric vector. It has two components, vertical component and horizontal component. Horizontal component is blocked and vertical component of this is coming out. Vertical component of this is coming out. Vertical component of this is coming out. Horizontal component is completely blocked. In this way, the electric vectors which are inclined, their vertical components are coming out through the polarizer, and by the combination of all that vertical components, the summation of all vertical components, vertical electric vectors, we get 50, because horizontal component is blocked. And so that the remark that we got is, intensity of polarized light is half the intensity of unpolarized light. That's all. This is all about polarized light. So take a screenshot. Take a screenshot. Okay. Then we will see what is partially polarized light. Then we will see what is partially polarized light. So let me clean the board at first. Partially polarized light. Partially polarized light. This lecture is not only a textual lecture, but this is very useful for various competitive examination like CET, NEET, JEE also, because I am trying to explain all the fundamental concept in deep regarding polarization and Malus law. Partially polarized light. Okay, one thing is remaining to explain about polarized light. What is the symbol of polarized light? This is a symbol of polarized light like this. This is the symbol of polarized light like this. No any dot at the center. This is the symbol of polarized light like this. Here the vibration of electric vector is exactly horizontal, and this is the direction of propagation of wave. So this is all about the symbol of plane polarized light, because that vibrations are occurring in a particular plane, and so it is called as PPL, plane polarized light. So these are the various symbols of plane polarized light. Symbol of plane polarized light may be like this. This is the horizontal vibrations like this. So electric vectors are vibrate horizontally, that I have shown it by dot. So all the symbols are nothing but the, or all symbols are showing for the plane polarized light. Then come to our next point, partially polarized light. Partially polarized light. I will write here. Partially polarized light. How the partially polarized light? Suppose this is a plane like this. This is a plane like this, and partially polarized light is drawn like this. See here. Like this. So vibrations of all electric vectors are very close and closer in a particular plane, perpendicular to the direction of propagation of wave. Such a light is called as partially polarized light. I will write a partially polarized light in which a partially polarized light in which vibrations of all electric vectors are so closer in a plane, and then the remaining sentence is perpendicular to the direction of propagation of wave. A partially polarized light in which vibrations of all electric vectors, that is E vectors, are so closer in a plane. They are so closer in a plane perpendicular to the direction of propagation of wave. This is the direction of propagation of wave. Direction of propagation of wave. This is the direction of propagation of wave, and that plane is like this. And in that plane, vibrations of electric vectors are so closer. Such a light is called as unpolarized light. The symbol of unpolarized light is like this. See here. Here is dot. Dotless dot, dotless dot, dotless dot, like this. Dotless dot, dotless dot, dotless dot. Such a symbol is of partially plane polarized light. So, how we can distinguish between unpolarized light, polarized light and partially polarized light, that we will see. Okay. Take a screenshot. Take a screenshot. Okay. There is a possibility of lengthening the lecture for longer time, dear students. So, remain alert up to the end of this lecture, so that you can get a clear-cut idea about polarization and Malus law, because these two articles are the magical articles, very funny articles. So, if the question is asked, distinguish between unpolarized light, polarized light and partially polarized light, then how we can distinguish it? That is most important thing. So, we can distinguish one by one simultaneously. So, we will make 3 sections like this. This is first, this is second, and that is third. So, here unpolarized light, here polarized light, and here partially polarized light. Okay. Unpolarized light, polarized light and partially polarized light. Unpolarized light, how the symbol is? Symbol, symbol, how the symbol is? This is a symbol, or the symbol we can draw like this. This is a symbol of dot is there, dot is there, dot is there. In every vibration there is a dot. This is electric vectors. This is electric vectors. This is a symbol of unpolarized light. Then how the symbol of polarized light is to be drawn? Here, symbol, symbol, no dot at the center, no dot at the center, no dot at the center, or this may be like this, like this, this may be like this. This is all about the symbol of this is all about the symbol of polarized light. Then partially polarized light, that I have already drawn. Symbol, symbol, the symbol should be like this. See here. Dot is here, no dot. Dot is here, no dot. Dot is here, no dot. Dot is here, like this. Alternate by giving dots, we can show the symbol of unpolarized light. This is one thing. Write down the definition of unpolarized light. What is the definition of unpolarized light? That we have already learned. Definition. I will not write here definition, but I will repeat it. Definition. Definition. Here definition. So I will repeat the definition of unpolarized light. Unpolarized light is a light in which vibrations of all electric vectors occurs symmetrically in all possible directions. This, in a particular single plane, and that plane is perpendicular to the direction of propagation of wave. That is the definition of plane polarized light. Plane polarized light is a light in which vibrations of all electric vectors occurs symmetrically in all possible directions. That is most important word. In all possible directions, in a plane, in a particular plane, that plane is perpendicular to the direction of propagation of wave. That is the definition of unpolarized light. What is polarized light? Vibrations of all electric vectors occur in a single direction. If vertical, then all are vertical. If inclined, then all are inclined. If horizontal, then all electric vectors are horizontal. If vertical, all vibrations are in a vertical direction. If inclined, then all vibrations are in inclined direction. If horizontal, like this. If horizontal, this or this, then all vibrations are in horizontal directions. In a plane, and that plane is again perpendicular to the direction of propagation of wave. That is the definition of unpolarized light. What is partially polarized light? Vibrations of all electric vectors are very closer. That I have already drawn the diagram to show the partially polarized light. Very closer in a plane, and then the remaining sentence is, what is remaining sentence? Perpendicular to the direction of propagation of wave. That is partially polarized light. Okay. Then the third distinguishing factor is most important. That definition you can write here. Okay. Then third one is, take a unpolarized light. Take a unpolarized light like this. Unpolarized light. Here I have taken, this is direction of propagation of wave. Suppose vertical plane of polaroid that I have taken, having vertical polarizing axis, polarizer, here unpolarized light, by making dot at the center. Then only those electric vectors are passing out through the polarizer whose direction is vertical, like this. That is plane polarized light. If this polarizer is rotated from 0 angle to 90 degree angle, then what happens? That is also the most important thing. If the polarizer is rotated like this, then only those electric vectors are inclined that are coming out. The polarizing axis is like this, then only those electric vectors which are parallel to the direction of this polarizing axis, they can pass. If the angle is 90 degree like this, then again only the horizontal direction of electric vectors. How we can show the horizontal direction? That horizontal direction we will show right like this. horizontal direction, horizontal direction, horizontal direction. So in each and every rotation, of polarizer, listen carefully dear student, in each and every rotation of polarizer, in this manner or this manner, in each and every rotation of polarizer, we get plane polarized light of same intensity. That intensity is nothing but I0 upon 2. If the intensity of unpolarized light is I0, then intensity of polarized light is I0 upon 2. That means after rotating the polarizer from 0 degree to 90 degree, the intensity of the emerging light from the polarizer, that is intensity of the polarized light, remains same, which is half the intensity of unpolarized light. I will write there. If on rotating polarizer from 0 degree to 90 degree, then intensity of polarized light remains constant. This is the most important property of unpolarized light. Then see here, what happens here? This is the third difference. What is the third difference here? Take polarized light like this. Take polarized light. See here, this is a polarized light. This is a polarized light. Okay. Then take a polarizer like this, having vertical axis. This is polarized light. When the axis is exactly vertical to the vertical axis of vibration of electric vectors of polarized light, then all the polarized light is coming out through the polarizer. All the intensity remain constant. When polarizing axis is vertical and vibration of electric vectors of polarized light is also vertical, both the directions are vertical, then the same polarized light will obtain here. The same polarized light will obtain here. Again we get polarized light. But if we rotate polarizer like this, then intensity goes on decreasing, and finally when the polarizer becomes exactly horizontal, when exactly horizontal to the axis of the polarizing axis of the polarized light, vibration of electric vectors. Okay. Oh, sorry. I will repeat again. When the polarizing axis is vertical to the vertical vibrations of polarized light, then we get again same polarized light. Intensity remain constant. But as long as the polarizer rotating polarizer from 0 degree to 90 degree, then intensity of light goes on decreasing, dear student. It not remain constant, and finally when plane of the polarizer becomes horizontal to the vertical vibration of electric vectors of polarized light, then it is blocked. No polarized light is coming out. Intensity becomes 0. So from this we can write here, on rotating polarizer from 0 degree to 90 degree, then intensity of the polarized light goes on decreasing and finally at 90-degree intensity capital I equal to 0, that is light is blocked. Light is blocked. This is the property of polarized light. What is about partially polarized light? See here, partially polarized light. Partially polarized light, like this. Polarizer is kept here. Intensity when polarizer is rotated, which is kept in front of partially polarized light, I will write here partially polarized light. As long as the on rotating polarizer from 0 degree to 90 degree, remember well, intensity of the partially polarized light or intensity of the emerging light coming out through the polarizer decreases from maximum value to minimum value, but not become 0. Here intensity of the polarized light goes on decreasing and finally at 90 degree intensity is 0. But here what happens? On rotating polarizer from 0 degree to 90 degree, then intensity decreases from maximum to minimum. At 90 degree intensity becomes minimum, but not becoming 0. That is the property of partially polarized light. So this is the difference between unpolarized light, polarized light and partially polarized light. So take a screenshot for your further study, and then we'll proceed to another funny article, that is Malus law. Take a screenshot. Take a screenshot. Take a screenshot. Then we are going to discuss now Malus law. Okay, Malus law. Let me clean the board at first. Malus law. Dear student, B remain alter up to the end of lecture. I have already told you that there is a possibility of lengthening the lecture in longer time, somewhat longer time. But if you remain attached to the lecture, then your idea regarding polarization and Malus law will be clear. Malus law. Malus is name of the scientist. Malus law. Malus law. Malus law. Malus law. Remember well, dear student, Malus law consult only for the plane polarized light. It is not consulting for unpolarized light. Malus law consult with only for the plane polarized light. This is most important thing. And to explain Malus law, we have to use two polarizer. First polarizer is called as polarizer itself, but second polarizer is called as analyzer, because the function of the second polarizer is to examine or to analyze the intensity of polarized light. So we call it as analyzer. I haven't told the definition or statement of Malus law yet, dear student. Malus law consult with only plane polarized light. This is my first sentence. The second sentence is it doesn't consult with unpolarized light. The third sentence is that to explain Malus law, we have to use two polarizer. First polarizer is itself called as polarizer. The second polarizer is called as analyzer, because the function of second polarizer is to analyze the plane polarized light. To analyze, to examine the intensity of plane polarized light. So second polarizer is called as analyzer. I will draw the diagram on the board. See here. I will draw the diagram on the board. What is this? Unpolarized light. Unpolarized light. What is this? What is this? This is a polarizer of vertical plane. Polarizer. So if the plane is vertical or polarizing axis is vertical, vertical components or vertical electric vectors are coming out. We get a plane polarized light. Plane polarized light. Then again keep a analyzer like this. This is P1, first polarizer. This is P2, second polarizer, but second polarizer we call it as analyzer. Again the second polarizer whose polarizing axis is vertical. Polarizing axis of first polarizer is vertical. Polarizing axis of second polarizer is also vertical. What is the angle between two axes? Angle between two polarizing axes is 0. And if the angle between two polarizing axes is 0, we again get the same intensity polarized light that we get here. Intensity of this plane polarized light and intensity of this plane polarized light is same. Here we get same intensity plane polarized light. This happens when theta is equal to 0 degree. But if the angle between polarizing axis of two polarizer, then what happens? The angle between two planes of polarizer and analyzer, if there is certain angle theta, then intensity of a plane polarized light coming out through analyzer is directly proportional to the, suppose I will denote intensity of plane polarized light coming out through analyzer is I0, coming out through analyzer is I, then intensity coming out through polarizer is I0. Here in this diagram what happens? I0 is equal to I. I0 is equal to I. So intensity coming out through analyzer is capital I, and intensity coming out through polarizer is I0. I0 and I is 0 when angle between two planes of polarizer and analyzer is 0. But if there is certain angle theta, then what happens? That is denoted by intensity of the plane polarized light is directly proportional to the square of the cosine angle between plane of the polarizer and plane of the analyzer. I will repeat again. Intensity of a plane polarized light, that is capital I, coming out from the analyzer is directly proportional to the square of the cosine angle between plane of the polarizer and plane of the analyzer. I will write here statement. Okay, what is statement? Intensity of the plane polarized light capital I coming out through what? Analyzer. Coming out through analyzer is directly proportional to the square of the cosine angle between plane of polarizer, planes of plural form, planes of polarizer and analyzer. Planes of polarizer and analyzer. So this may be written as like this: I equal to what we get? I equal to, suppose this is plane polarized light having intensity I0 and amplitude A0. This is a plane polarized light having intensity I and amplitude A. Suppose the angle between them is theta. Then angle between them is theta. That means this is plane of polarizer P1 and this is plane of analyzer P2. Angle between them is theta. Then only those components are coming out which are inclined, A cos theta, A cos theta, A cos theta, A cos theta, like this. So here the amplitude is A cos theta and intensity is capital I. Here amplitude is A naught and intensity is I naught. So I naught is equal to what we get? I naught is equal to K A naught square. I naught is equal to K A naught square, and here we get what? I is equal to, amplitude is A cos theta. So I is equal to K A cos theta bracket square, because amplitude is directly proportional to amplitude is directly proportional to square of the amplitude. So we get here I is equal to K A square. So we get what here? I is equal to K A square cos square theta and A naught K A naught square cos square theta, and here K A naught square is nothing but I naught. So we get what here? I is equal to I naught cos square theta. This I naught is constant. So we get I is directly proportional to cos square theta. So instead of instead of remembering these derivations, we can only remember this statement. Intensity of the plane polarized light I coming out through analyzer is directly proportional to the square of the cosine angle between plane of polarizer and analyzer. If theta is equal to 90 degree, then cos 90 is equal to 0, and intensity coming out through the analyzer at that time becomes 0. So this is all about Malus law. This is all about Malus law, and here Malus law consult with plane polarized light. So remain alert always for my channel Physics Make It Simple. We will take the next article by taking in a next days or in next time. Goodbye.